We're given this cable situation. There's a house and there's a driveway which is 2 miles long going down to the street, and then at the end of the driveway you can turn and drive down the road until you get to a post, a cable post. If you continue further, you'll get to the cable box. Now we know the cable box is X miles away from the cable post in the street. So in order to wire this house up for cable, we're going to take a path across the grass diagonally from the house to the post, and then travel along the street those X miles to arrive at the cable box. Now the entire distance from the end of the driveway, where the street meets the driveway, to the location of the cable box, that's a total of 5 miles. Okay, so we also know that the cost to run the cable from the post to the cable box, which is X miles, that's going to cost $500 times the distance X, 500X. And we also know the cost to run the cable along the grassy path, which is pointed to in the sketch, is going to cost $700 times that distance in miles across the grassy path. So we're asked to find the cost expressed as a function of x, where x is a distance in miles. So that's c parenthesis x. In other words, c of x, the cost as a function of x to install the cable. All right, so here's our solution. Let's draw the picture of the triangle without the house. Ignore the flashing thing at the top if it's bothering you. Here's our y-coordinate, our x-axis. Here's the distance 5. And we form this right triangle. It's x miles from the post to the cable box. So that means the ordered pair is going to be 5 minus x is a distance from the origin 0, 0 to the post. It's the x-coordinate is 5 minus x and the y-coordinate is 0. And then we see the other coordinate up at the top as 0, 2. And then we have that location 5 where the cable box is. So what is the distance across the grass? Well, that's going to be found using the 2 points, x of 1, y sub 1 equals 5 minus x, comma 0, and x of 2, y sub 2 equals 0, 2. That distance using the distance formula is the difference between the x-coordinates, which is 5 minus x minus 0 parentheses squared, plus the distance between the difference between the y-coordinates, 0 minus 2 parentheses squared. Now that means we're going to have to multiply 5 minus x times 5 minus x and then add negative 2 squared, which is 4. So when we FOIL that under the radical sign and combine like terms, we're going to finally end up with the square root of x squared minus 10x plus 29. So that's that distance diagonally across the grass. That means the total cost in terms of x miles will be the 500 times the distance x, that's the distance from the post to the box, plus the 700 times the distance square root of x squared minus 10x plus 29. Now then, if they ask us to find the particular cost when x equals any specific number like 1 mile, we just let x equal that number 1, plug it into the formula that we acquired. It's called the model formula in the box, and then simplify. We get 500 times 1 is 500 plus 700 times, if you simplify under the radical, you get the square root of 20. Then that simplifies, the radical simplifies as the square root of 5 times the square root of 4, but the square root of 4 is just 2. Bring the 2 over and multiply it by the 700. You'll get 500 plus, let's see, 700 times 2 would be 1,400, and that would be times the square root of x. Okay, so that is not showing very well. You'll have to look really hard, but it is there. But if you took a calculator, you'd get $3,630.50, which you cannot do in a test. So the one that right here on the left is the one that you'd have on an exam, which is